All right, this is 7th grade 3.1, converting between measurement systems. So this table on the front is going to be important. It's something that is going to be used throughout this chapter. So we're actually going to skip to the next page and we're going to look at the example. While lifting weights, John adds 11.35 kilograms to his bar. So we have kilograms. About how many pounds? So we want to know how many pounds he added. So we're going to be converting from kilograms to pounds. So what we're going to do is we're going to take what I was given. And in the problem, I was given 11.35 kilograms. So I was given 11.35, and I'm going to put kilograms. Okay, and I'm going to multiply that by what's called my conversion factor. Now, conversion factor is two units that are equal to each other. A good example is 1 foot equals 12 inches. They're different types of units, but they are equal. So we're going to look at the conversion factor for pound and kilograms. Now, this you can get off the front page. So I have kilograms here. I'm going to multiply it times my conversion factor. So what we're going to do is we're going to put this over 1. We're going to make it into a fraction. And we're going to put this into a fraction. Kilograms is on top here, so we're going to want it on bottom over here. And reason why is, in a little bit, they're going to cancel out. So I look over here, and what number went with my kilogram? 0.454. So I'm going to put 0.454. And then 1 pound went on top. Now when I multiply these, I'm going to have kilograms on top. I have 11.35 kilograms because top times top, bottom times bottom. Kilograms times 1 pound. And remember, our end result is to try to get pounds. So, and then my bottom is going to be 1, just 1 by itself, times 0.45 kilograms. Sorry about the bells. So what I can do is kilogram divided by kilogram is going to cancel each other out. So what it leaves me with is it leaves me just with my pound. So that's why the kilogram has to be on top over here and on bottom over here. So now I can just multiply like normal. 11.35 is going to be on top. And that's going to be pounds. And 0.454 is going to be on bottom. And we actually aren't going to solve that. I mean, you can if you want to, but I more want you to be able to set these up than I do want you to be able to solve it. All right, we're going to look at another problem in a little bit. All right, we're on page 86 still, and we're just going to look at example 2. So we have 6 quarts is equal to about how many liters? So I'm going quarts to liters. So I always start with my given. And my given this time was 6 quarts. I do include my units. And I'm going to stick that over 1 because it doesn't change the value. It's still equal to 6 quarts. I'm going to multiply it by my conversion factor. So I'm going to go back and look at that table on that first page. And what it tells me is that 1 quart is equal to about, which the squiggly lines means about equal, to 0.946 liters. Okay, I got that off that first page. So my quarts is on top here, so I want my quarts on bottom over here. So I'm going to go and see what number is with my quart. My 1 is, so 1 goes here. The other number goes on top, 0.946 liters. And that's actually as far as I really want y'all to go. This would be 6 times 0.946, and that'd be your answer. Hope this helps you understand. We're going to look at another way of doing it on the next page. So we're going to scroll down. I'm going to scroll down. we can also do this with proportions. So let's look at the example. Bob's driveway is 45 feet long by 18 feet long. So we have 45 feet, we have 18 feet wide. He plans to pave the entire driveway. The asphalt paving costs $24 per meter. And I don't really care about the total cost right now. I just want to know what are the 45 and the 18 going to be in meters. So I'm going to take my given, and it's going to be two separate problems because I got to do my length and then I'm going to have to do my width. So I was given 45 feet. And I'm going to again stick that over. We're not going to stick it over 1 this time. We're just going to stick it over X because we don't know how many meters that feet is. Now I can put a little M here if you want to for meters. And this time, since it's a proportion, which is two fractions that are equal, I'm going to, and since they are equal, the units go in the same spot also. So last time my feet would have gone down here, but this time it's going to go here. So what do I know about feet and meters? 1 foot is 0.305 meters. So my 1 foot goes with my foot, 0.305, sorry. Then I would cross multiply. They did it by, you could also do 1 times 45, so 0.305 times 45 like they did here. Or you could cross multiply. Either way works. And then we would do this again for our 18 feet. So I was given 18 feet. I don't know how many meters that's going to equal, so I'm just going to put X meters. My conversion factor is that 1 foot is equal to 0.305. Now, this is a great way to do it also. The only difference is that this is going to have our units in the same location, like on top and top, bottom on bottom, while the other one had them across from each other so we could cancel because we were multiplying for that. Again, you could do 1 times 18, 0.305 times 18, and you can get an answer. So there's 2 ways to do it. All right.